AI coding agents are impressive, but they can struggle when the code breaks in a large and complex application. This is characterized by AI hallucination or unreliable outputs. This is not because the model you're using is unintelligent, it's simply missing some context. To solve problems in such environments, agents must have the context of what the program does, not just what the code says. The hardest problems in million-line codebases live in runtime state, not in a static codebase. Without runtime context, even good AI can only guess. Undo changes that by providing your coding agent that runtime context it's missing. With undo, you can give your AI agent a detailed recording of what really happened when the program was running. Undo captures complete program execution, every state change, execution path, function call, and data flow, into a recording file, and makes that recording available to coding agents. Agents then query the recording to reason about dynamic behavior the way they already do about static code. Recordings are the antidote to hallucination. They are the only way agents can access the runtime context needed to understand what actually happened and solve problems which code alone cannot explain. You can capture a recording of your program while it's running, manually during development, or automatically during CI and automated test runs. Then, instead of stepping through it yourself, you can hand the recording to an AI agent that investigates it for you, finding root causes, tracing exceptions back to their origin, and reporting what it found. Undo plugs into your existing coding agent via an MCP server. Now let's see how this works in action. I'm using Claude Code here. We'll debug a failure site unseen, meaning Claude has no access to the source code and no prior knowledge of the program, and is reasoning using only the undo recording. We'll run through it fully and then rewind and walk through what it did. First, Claude reads the console output to understand what failed. From that alone, Claude decides the next step is to set an exception breakpoint. The exception is thrown inside ArrayList.check fork modification. Claude now inspects the stack to see where this occurred. This method throws only when it detects interference that already happened. Next, Claude inspects the iterator and the list state to understand why the exception was thrown. Here's the key detail. The iterator's expected modification count no longer matches the list's actual modification count. Now Claude identifies the critical question. When did that value change? Claude requests a watch point and asks undo to run the program backwards. Claude asks undo to rewind to the point where mod count last changed. Undo rewinds execution to the exact instruction that modified the list. And notice, this happens on a different thread. Claude explains the full chain of events, which thread ran, which method modified the list, and how that caused the failure later. For completeness, here's the code. Claude didn't read this. It inferred everything from the recording. This is what AI looks like when it has perfect runtime context. No hallucination, no guesswork, just facts.